Hello people, happy Wednesday. How everyone's doing? Today we're going to talk about pull rates. Now, pull rates, which is basically statistic, as you may know, if you don't know, I'm a mathematician. I'm doing my master in mathematics. I should probably say that more often. It's my field of expertise. As a matter of fact, my master is heavily focused on statistics, probability theory, and mathematical analysis. Probability theory and statistics are a branch of a sub-branch of mathematical analysis. Now, what we're going to talk about today is a couple of things, and I will be happy to make a more in-depth video. So probably make a presentation so you get some visuals, better understand what is going on. But I just wanted to give you an idea because I watched a few videos, and it's nice that people talk about pull rates, but it would be also nicer if people actually understood pull rates. Now, you guys are familiar with TCG player data about pull rates, right? I think it's a branch of TCG player. It's called TCG player Infinite or Infinity. I don't remember exactly, but still, it's part of TCG player. Now, what they do is, and what most people do, is they use a field of statistics, which is basically the origin of how statistics was born in the early 20s of the 1900s, story time, and it's called the frequentist. I'll leave you the word down below. I'm not sure how you pronounce it. Statistic. What does it mean? It means, okay, this has happened. I'm saying that this could happen again in the future. Okay, and it's based on, as the words say, frequency. So you expect things to happen again, so you can repeat the experiment with the same conditions. Now, is that realistic for Pokemon? Well, when you use that type of a paradigm in statistics, you also need to make further assumptions, which some of them are like when you consider pull rates. Sorry, I got so many cables here. When you consider pull rates, you're saying basically that everything is independent. Every time you pull a card is independent of what came in the past. So you open a pack, okay? You get up another one. What is the chances of pulling a card right now is independent of what you just pulled. Is that really realistic? Now it depends on many things, which I'll not cover today. But the opposite side of frequentist statistics is Bayesian statistic from Bayes, Bayes. Hope I said that right. Which kind of revolutionized the way people think and see statistics. Now, if you're not familiar, this type of statistic, Bayesian statistics, is commonly used in artificial intelligence, machine learning as a better way. And also in finance. Basically, there's two different ways to think about it. And I will not go into details. I could, but that's not the point. And basically, one characteristic of Bayesian statistics is basically saying that what is happening right now is influenced by the past. Okay? And it also lacks, it drops some assumption that the frequentistic approach had, such as independence, obviously, and it adds different assumptions that the other approach, the standard, let's call it standard. I'm dying, people. It's been good. The standard approach had. So, which one are we going to use? That should be a debate for it would take much I would need to go in depth. But just be aware, and you can do your own research. These are two main type of statistics, the two approaches to statistics. Now, another thing I heard today is you're better off buying your chase card than opening packs. Now, yes, on average, if you want to pull a chase card, just buy it. I agree with that. However, the way things were put out in that video were extremely misleading. So, for instance, if you can find, so basically the point was, look, if the probability of pulling the Lugia from Civil Tempest in is 1 out of 1,000 packs. Okay. So let's say you need to open maybe 1,500 packs and you get it. 300 packs, you get it. Now you may say, Barry, it's 1 out of 1,000. You just need to open 1,000, you get it. That's not how statistics work. If you say you will get it, meaning 100% certainty you'll get it. That's not how it works. So let's say you need to open a large amount of packs. It makes sense to open them if the expected value on the expected value. Barry, do we say these words in this channel? There's kids watching. Sorry. Anyways, if the expected value, which is basically the average value in terms, the average price of the cards contained in a pack. I don't know what card they are. Yes, you just use the odds, which are it's very complicated. I should probably do a live stream, people. Just talk about these stuff because I think it's fine. People just use that data, the pool rates data. But the problem is that, and I mean, it's not their fault. Obviously, I'm lucky enough to have access to extremely high education. So I know many stuff because also, I mean, people teach me and I study. So I also have to put my work. But I understand if you just graduated high school and wherever in the world, you might have a basic understanding, which is, and to have a deeper understanding, obviously you need a higher education studies, which is, I understand. I'm in a very fortunate position, which is why I'm trying to tell you people of the internet, look, other things exist. There's more to it that perhaps you should know, but the people you listen to don't know because they don't know it, which is not their fault. They're just reporting what they hear, which is fine. They're just reporting facts. But it's kind of like, I know, I can't find a metaphor, but it's like, let's say I'm reporting the news, right? This happened in Detroit yesterday. But I'm not contextualizing the fact. I'm not saying, okay, this happened because something else happened, because 10 years ago something else happened, and it could have influenced what could have happened tomorrow. Probably not the best example, but you guys get what I'm saying. There's much more to it. Now, so let me know down in the comments if you'd like me to make I should probably make a live, so you guys can also ask me questions in real time. And I'm talking 8 minutes. I can talk about it for hours, obviously, because I know many things about it. So, does it make sense to open packs for a chase card? It depends. If that's the question, it depends. Now, it makes sense if on average your expected value on the pack is greater than the cost of the pack. So not only you are on average making money, but you're also having fun. How many packs you need to open for the average to make sense? That's a good question. We'll not cover it today. Now, why the more packs you open, the better your pool rates, the more your pool rates is accurate. Okay? Why is so? Have you guys ever wondered why it's so? Why is that so? Has anyone ever told you, your favorite YouTuber has ever told you why the more the better? So let me tell you this, and I'll be happy to go more in depth in a live stream. So when you open packs and you're like, okay, I pulled one Sumbrian out of 1,000 packs. Probably the playing one could be 1 out of 1,000. That is called the sample mean. Now the sample mean has very properties. Now, because of the distribution of what? This is tricky territory, people. I'll try to make it as simple as possible in as short a little time as possible. But if you don't understand it, it's fine. It's not easy. That's why I should probably make a live. I don't know why I'm making this video. Either way, probably you guys learn something from it. Hopefully, that's the point of the channel. So you need a random variable. A random variable is basically a box that tells you in this specific example is, we open a pack, are we pulling the Sumbrian? Yes or no? Okay, that is a specific type of random variable. It's called Bernoulli, and it's really yes or no, 1 or 0. Are we pulling it? Yes. Are we pulling it? No. Are we pulling it? Yes. 1 0 1 0 1 0. Okay. So when you keep track of this, of the outcome of this experiment, you get a Bernoulli, a series of sequence of random variables that are distributed 1 0 1 0 1 0 1 0 1 0. Okay. Now, that distribution, when you look for, the goal is estimate pull rates, right? Okay, we want to estimate the pull rate of the Sumbrian. Okay, that's just an example. Okay, we open packs, blah, blah, blah. We keep track of the outcome. We're pulling it yes, no, yes, no, yes, no, yes, no. Okay. We sum the outcome. We divide it by the number of packs so we sum the number of, the outcome. So 1 0 1 0. We divide it by the packs we open. That is the sample mean. And that specific, it's called an estimator because you're estimating the mean. That is quite, it's pretty confusing, but you don't know the mean, right? The mean is the pull rates. You don't know the pull rates. You don't know what is the probability of pulling a Sumbrian. You don't know it. You're estimating from the data, so from the packs you open. That is very important. That should probably be the intro. It's very important, people. Almost makes me cry. You don't know the pull rates. You're estimating them. When you estimate, that is called statistic. Okay. So we're estimating. This type of estimator I just mentioned, so the sample mean on the Bernoulli distribution, and a sum of Bernoulli is called a binomial. Barrett, there's kids watching. There's my child watching. Just can you please not say these words? Sorry. Anyways, God. It's called MLE, maximum likelihood estimator. Barrett, I just told you my kid is watching. Sorry. Okay, so the MLE has some properties. They're asymptotically. Again, Barrett, can you please stop it? I'm serious. It means that as your sample size, numbers of pack pools gets larger, they follow certain properties. One of them is unbiasedness. What does it mean? On average, your estimator of the pull rate will be the pull rate that you don't know, but you're estimating, okay? Again, it's hard. This is complicated. It's confusing. Let me know if you want me to make a live stream, and let me know if you have any comments, any questions down in the comments. Okay, so not only that, but also, once again, asymptotically, so as the sample size gets larger, the more packs you open, your variance gets smaller. Not only gets smaller, but it gets, so your estimator, your sample mean, gets more informative of the data. So it is able to summarize the data in a more efficient is a keyword, way. Okay? Now, that was very complicated. I threw a ton at you. This is high-level education subject. It's tough. It's okay. Barrett, it's complex. Why should I even care? I don't know. If you're curious, guys, you might know this thing exists, and that's why when you hear, you guys what? Let me know if you want me a live stream. I'll be able to talk about it for hours, answer all your questions, all your doubts. Subscribe, people. It really helps. And leave a like. It doesn't cost you anything, and it helps. Makes my day. Ciao, people.